A vessel is in the form of an inverted cone. Its height is 8 centimeters and radius of the top, which is open, is 5 centimeters. It is filled with water up to the brim. When lead shots, each of which is a sphere of radius 0.5 centimeters, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shots dropped in the vessel. So we start with the first. We have here a cone. This is a cone that is filled with water. So we have, this is a cone here. The dimensions of the cone are written below, and this cone is filled with water. It's absolutely filled with water to its brim. Now into this cone there are lead shots that have been put. So here there's one lead shot here. One. There are a number of lead shots. We do not know how many, and that's a question. Okay, so I will just put, we don't know how many lead shots. Say there are X lead shots. And because this lead shot has been put into the cone, what you expect? You expect the water to overflow. The water will now overflow, will fall out of the, will fall out of the cone. This is the water that is overflowing from the cone. Let's get back to the dimensions. So we had, this is the cone, radius 5 centimeters and height will be 8 centimeters. So we have volume of cone, or volume of the total water, is 1/3 pi r square h, and that is 1/3 pi. Your r here of the cone is 5 square and the h is 8. So this is volume of cone. Now we have the lead shots. We have the lead shots, so we have volume. The lead shots are spheres, so volume of sphere or the lead shot is 4/3 pi r cube. And the r of the lead shots, here the r of the lead shot, here I put the radius. The radius of these lead shots is 0.5 centimeters. So the volume becomes 4/3 pi r cube, 0.5 centimeter. That is volume of one sphere. But how many spheres do we have here? We have X spheres. So volume of X spheres, in this case X spheres, will be equal to X into 4/3 pi r cube. This is volume of X spheres. So we have done two things. We found the volume of the cone, the total volume of the cone, and we found the total volume of all the spheres. Now let's read further. Here they say, when the lead shots, each of the sphere, are dropped into the vessel, 1/4 of the water flows out. So the water that is flowing out here, this water that is coming out here, is 1/4 of the cone. So volume of water overflowing. Why has the water overflown? Because you put the lead shots. Is 1/4 of the cone. Volume of the cone is here. So it's 1/4 volume of cone. That's what they have told us. So that is 1/4 into volume of cone. We know is 1/3 pi r cube r square h. This is volume of the overflowing water. Volume of water overflowing. Now the next part is, why has the water overflown? The water has overflown because you have put the spheres in this, which means now we can make an equation, and that equation will be volume of water overflowing will be equal to volume of the spheres or the lead shots. So let's put that. Water overflowing, we said, we found here water overflowing is 1/4. This is the water that is overflown into 1/3 pi r square into 8, and this is equal to volume of the sphere, of the spheres. So we have how many spheres? This is the volume of all the spheres. So that would be x 4/3 pi 0.5 cube. So again we'll write volume of overflowing water equal to volume of x spheres, and we saw overflowing water volume was 1/4 into 1/3 pi r square into 8 equal to x 4/3 pi 0.5 cube. And this was a question to find how many spheres had to be put in. Let's continue. So 1/4 into 1/3 pi 5 square into 8. Now this goes on the other side. It will become 3/4. This on the other side 1/pi. This on the other side 0.5 the whole cube, which is equal to x. And the x turns out to be 100 spheres or 100 lead shots. So we'll go to the earlier. So here, let's go back to this sum. So when we said the spheres were put in and 1/4 of the water came out, so the number of spheres here is equal to 100. 100 lead shots were put into this cone.